TXRX systems, tower top amplifiers, and receive multicouplers are used in land mobile radio to enhance the receive characteristics of base station and repeater sites, and to give portables, mobiles, and handhelds better range and capabilities. This section will give an overview of the system setup and optimization, which if not set up properly will not be effective and may even result in reducing sensitivity instead of improving it. The technician should always follow the operation manual provided with the system for complete procedures. In this third section of our training material about receive sensitivity improvement products, we will cover the topics listed in this table of contents. Hopefully this will assist in finding the information you need. First responders have always been dependent on voice communication through land mobile radio for their safety, efficiency on the job, and general performance of their duties. TXRX Systems has been a supplier of RF infrastructure equipment since 1976, when the company was founded. Tower top amplifier and receive multicoupler systems have been used to ensure first responders are heard, first time, every time, protecting sensitivity, guaranteeing coverage, enhancing performance. As the diagram illustrates, LMR radio systems now carry much more than just voice, but the primary tool is still a radio. As illustrated and discussed in previous training modules, the base stations or repeater sites have much higher power than the portables, mobiles, and handhelds. But the goal is to be sure each radio receives all signals within the system. This section in Receive Sensitivity Improvement Products will cover system setup and optimization, the steps to be taken to make sure signals get into system receivers as solid as the transmitted signals. This section is intended as an overview and not an in-depth presentation of system optimization. The technician should use this as an introduction, but use the operation and installation manual during setup. Sensitivity in land mobile radio is one of the most important factors to be considered. TXRX sensitivity improvement products maintain or improve sensitivity for all systems. Sensitivity is a radio's ability to receive low-level signals and decode or demodulate them so that they are easily understood by first responders using the radio. There are many terms used to describe acceptable levels of received and understood, beginning with a measurement of how sensitive a receiver is, with no signal coming in. Receiver sensitivity is also known as chassis sensitivity and is the specification given by radio manufacturers setting the lowest received signal the radio is capable of receiving. System sensitivity measurements include additional components of the system, as well as the radio. System sensitivity with a load connected adds the rest of the receive system parts, but does not add the antenna and outside noise. The final measurement is system sensitivity with antenna connected, which adds the rest of the receive system parts, as well as the antenna and outside noise. Radio noise comes from hundreds of sources, from industrial processes, cell phones and sites, fluorescent lighting, computers, sunspots and other atmospheric conditions, and broadcast transmitters. As the RF noise from any source increases, sensitivity and coverage decrease. Major metropolitan areas, large cities, suffer the most from elevated noise levels. The maps on the slide show what happens as more noise is added, with each 6 dB increase in noise resulting in 1/4 of the coverage. TXRX has won the confidence of its customers and end users over the years by producing rock-solid equipment for use in land mobile radio. Once the equipment is ordered and received, it needs to be installed and optimized for proper usage, and this requires a step-by-step structured approach. All steps are covered here, but are in an abbreviated format, a short overview of requirements and steps. For life-critical application, testing starts when the equipment has been received, before it is on the tower and in the rack. It is much easier to step through the tests and familiarize yourself with the TTA system on the bench instead of 250 feet up a tower. This section will lead you through an overview of the pre-installation checkout, installation notes, optimization of the system, operational tests to be sure everything is working properly, and finally, operation of the system. All steps should be performed for complete optimization. This material is not intended to replace the operation manual, but to add information about the why of system optimization. All freight shippers or carriers have their own unique way of destroying equipment before it arrives on site. In an effort to get the gear delivered as quickly as possible, shipping cartons are thrown or dropped, and while the box may not look damaged on the outside, the equipment in the box may have taken a beating during handling, over pothole-filled roads, during loading and unloading. Be thorough in your inspection of shipping materials. Be sure you know the deadlines in reporting damage to a carrier. Before unpacking the box, look at the carton on all sides, looking for rumpled corners, forklift holes, large skid marks. If there is damage, take pictures of the box or crate. Document what you found. Once that step is complete, carefully inspect the equipment packed inside the box. Look for loose or damaged packing foam, broken cross braces, and any other signs of rough handling. Pick up the individual pieces of equipment and look at each component. Check for loose parts or cables. If possible, pick up the units one at a time and carefully shake them, listening for anything that rattles. At TXRX, we have had equipment returned in shop-built crates as the pictures show. This crate had been dropped, splintering the lower corner in the front of the picture. The duplexer shipped in the carton had several of the tuning rods on the cavities bent as shown in the picture on the right. Carefully inspect everything. One of the first tests is to check that everything works before going up the tower. The tower top unit is fed operational voltage through the main transmission line and has no power supply by itself. The tower top unit and control unit should be connected with short sections of feed line on the bench, in the shop, and run through basic tests and setup. Following the operations manual, connect the tower top transmission line out to the control unit main input and the tower top test port to the test cable input on the control deck. The systems are designed to operate on nearly any public utility power on several international standards, from 90 to 240 volts AC and 50 or 60 Hz line frequency. The units are supplied with standard US AC plugs or with bare wire leads for plug installation at the site. Equipment racks typically have power strips in the rack. If the racks are powered with 48-volt DC, bare leads are installed on the control unit to interconnect in the rack. Once power is provided to the unit, it will begin the power-up sequence. Front panel LEDs, depending on the model, will illuminate or flash. Newer models will begin their boot up of microcontrollers, and after a few seconds, the display will show connecting to tower controller. After the power-up sequence is complete, the model number of the system will show in the front panel display. Once the TTA has completely powered up and booted, testing will continue on the bench. Depending on the model of the TTA, testing can proceed using front panel control buttons, which are an up arrow, down arrow, enter, and cancel, making it possible to complete all bench testing using these controls. Some models are accessible using the front panel LAN connector, but initial setup typically uses front panel buttons only. The operations manual shows the navigation menu structure that appears in the LCD window and will be very helpful during this phase of operation and testing. One of the first tests after power-up is either a SYNAD test using a SYNAD meter or a bit error rate test using a bit error rate meter. These tests are for what is called static sensitivity, as they are performed without connecting the antenna. A signal generator is used as the source and is attached to the antenna input connector on the tower top unit, as shown on the diagram in the ops manual, while still on the bench. The result of this testing will be used for future troubleshooting, so be careful in performing this test. SYNAD is an abbreviation for signal plus noise and distortion and defines the quality of the signal, what is usable audio quality and what is not. 12 dB SYNAD is typically the reference point used as the threshold for usable communication. Above 12 dB SYNAD, audio will be distorted. In this use, the signal generator is a controlled source at a known level with a low noise output. No outside noise from the antenna comes into the system, which results in the system static sensitivity being measured, the starting point for all sensitivity. The output of the signal generator is increased until the system reaches 12 dB SYNAD, and then the generator value is recorded. Bit error rate is similar to SYNAD, but is used to measure noise tolerance in a digital system. At a certain point, usually 5% bit error rate, a digital processor is no longer able to distinguish between ones and zeros in the bit stream and stops decoding. At this point, the receiver will begin to pop holes in the audio, or the audio will stop completely, an unacceptable situation in first responder radio. Follow the steps outlined in the operations manual and connect a signal generator, SYNAD or bit error rate meter, and a system receiver. Perform the static sensitivity measurement for the TTA system as outlined. Record the results, which can be used for future system troubleshooting by comparing new measurements against your original measurement. Remember that this will show static system sensitivity changes, pointing to faults that may have happened inside a system and not changes caused by interference or changes in noise levels outside the system. This step is vitally important in helping to distinguish between system problems or environmental issues, such as strong interferers or elevated noise from public power systems or other causes. TTA systems from TXRX have used various ways of adjusting the gain in the system. The amplifiers in these TTA systems operate at a fixed gain level and are adjusted by adding attenuation into the amplification path. This can be done with mechanical rotary attenuators in 1 dB steps or by using programmable attenuators addressed through software. Be sure to consult the operations manual specific to your system. TXRX TTA systems for first responder radios are fail-safe and use redundant amplifiers. It is important that during initial testing, the backup amplifier be put into service to be sure that the sensitivity stays about the same. And always remember that too much gain is not a good thing. Line sweeping is a test that allows transmission lines and the antenna to be tested on the tower after installation. The piece of test equipment used is called a frequency domain reflectometer, and it cannot see through an active circuit or a split in the transmission path, both of which the TTA represent. Bypassing the tower top unit reroutes the signal path around the amplifiers and puts the main line and the antenna in line with the test port on the front of the control unit. For some bench tests, a 50 ohm load needs to be attached to the TTA antenna port. During initial setup, this test allows the function to be checked to ensure that it is working properly. As part of the standard operation, the tower top unit will return to normal function if left in the test mode for more than 10 minutes. The TTA has a terminate function, which places an internal 50 ohm load in line in place of the antenna. As outlined, this will be used in troubleshooting the system in the future should a drop in sensitivity be seen. During initial testing, a significant drop in gain will be seen if the function is working properly. A front panel LED indicator will light to indicate that the TTA is terminated into the load. The unit will return to normal operation after 10 minutes if the terminate function is not turned off. TXRX supplies the tower top unit and the deck or control unit to be mounted in the rack, but all other equipment, transmission lines, connectors, ground kits, lightning arresters, and waterproofing will be provided by the end user. Optional mounting brackets for tower top units are available, but due to the many varieties of towers and mounting locations, additional hardware may be required. Don't forget to order the test line along with the normal feed line and lightning suppression to be used at all cable connections. Grounding is a must on towers and in the equipment room. All sites should be grounded to R56 standards inside the shelter. Transmission lines can develop a charge on the outer insulation or jacket on the tower from wind, resulting in static discharge. All main lines and test lines must be grounded on the tower, at the top near the antenna, at the base of the tower, at the entry plate to the shelter, and depending on tower height, every 75 feet. Ground kits are sized to the feed line, so be sure to get the right ones. After installing the ground kits, they must be waterproofed. Inside the shelter, all racks and individual components must be grounded to R56 standards. If you have not taken R56 training, we highly recommend it. The R56 standards were developed in 1987 by Motorola and originally titled Standards and Guidelines for Communication Sites. They have since that time become the industry standard, defining minimum standards for expected system performance, reliability, and longevity. Several versions of the standards are available online, and a 5-day class is taught by several organizations. Scheduling site installations is complicated, and the details take a great amount of coordination. Determining where on the tower antennas will be mounted will be dependent on space availability, proximity to other antennas and systems, isolation needed between transmit and receive antennas, and several other factors. Be sure to mount antennas following the manufacturer's guidelines, following proper standoff requirements, using the proper mounting hardware. The same goes for transmission lines on the tower. Be sure to use the proper size clamps spaced at proper intervals on the tower. Clamps that are not sized correctly will allow the feed line to hang unsupported, while too small clamps will destroy the feed line. The TTA should be mounted as near to the antenna as possible, keeping jumpers as short as practical. Mount the TTA, connect all feed lines following all torque requirements, and be sure to use the ground lug on the outside of the TTA to properly ground it to the tower. When mounting the TTA on the tower, be certain that it is mounted solidly, using all mounting tabs, and be sure that it is mounted with the connector side of the unit facing down. The units have drain holes or weep holes, as condensation will occur inside the box. All connections on the tower must be waterproofed. Two of the most important factors of a good installation are connectorization and waterproofing. Be sure to start several inches away from the connector body and on the insulation of the feed line. Begin tightly wrapping waterproofing or rubber splicing tape, overlapping carefully, covering the wraps underneath partially with each succeeding wrap. Completely cover the connectors with the tape and finish with a spray-on waterproofing such as Scotch Coat. If you use multiple layers of tape, the last layer must go up toward the connector. When mounting the TXRX Systems control unit in the equipment shelter, again, be certain to follow R56 standards in grounding. The units are designed to be installed in standard 19-inch equipment racks, following the more detailed instruction in the operation manual. Be careful when connecting the rear panel ground lug to the ground bus bar in the rack. being sure that all connections are snugged tightly. Main transmission and test lines will be connected to the rear of the deck, so be careful when running feed line or jumpers into and out of the racks, following minimum bend radius limits. Reviewing standard installation practices, strip and install the alarm wires to the connectors at the rear of the deck. Depending on the type of control unit, connect all required outputs on the deck to the appropriate inputs on the receivers. Once the equipment is powered through the 48-volt DC or 110-volt AC supplied, the unit will start operation of the system. All installations must have surge protectors installed. Even if the system is not in a high lightning area, the absolute worst time to need protection and not have it is during a freak storm. Static discharge can occur at any time, so be sure to understand the requirements. All transmission lines must be surge protected at building entry sites. All feed lines must be protected. If the lightning arresters have a ground point on the body of the unit, be sure it is used. Once the TTA is on the tower and the control unit is in the racks in the shelter, post-installation optimization begins. System and site designs done ahead of installation are somewhat idealized, as they are done in the absence of knowing exactly what the environment will be like at a site following installation. A perfect design can be compromised by interference and intermodulation, so testing is required to confirm operation. Factors include antenna separation on the tower for enough isolation. Transmitters need enough filtering to provide sideband noise suppression. And as with all amplifiers, while the right amount of amplification will result in better coverage, too much gain will result in a reduction of system sensitivity. All TXRX receive sensitivity improvement products need to be optimized to the receivers they will be working with, using company-specific optimization. Check both TXRX and the receiver manufacturer operating manuals and follow the procedures given. Enough gain should be used to offset any transmission line losses, while using enough gain to give the system optimum sensitivity. Amplifier gain may be adjusted manually or with digital attenuators. Newer models will use auto setup, with the technician entering site data and the unit setting itself up. The final step to be done on site is to observe what signals are being received by the system antenna. Using an RF output port and with the system antenna connected, observe the signals on a spectrum analyzer. Nothing in the receive band should be above neg 35 dBm to prevent desensitization. Within the transmit band, no signal should be above neg 55 dBm. Incoming signals should be observed for at least 30 minutes or longer to determine levels. Many features are built into TXRX TTA systems to allow on-site optimization, including operational tests to determine sensitivity and degradation. System sensitivity without any signals from the outside is called static sensitivity and is a baseline sensitivity measurement. When static sensitivity is degraded by received noise, the measurement was known as effective receiver sensitivity, or ERS, and was used to determine how much the signal is degraded by noise. Some of the names of the sensitivity requirements and measurements are currently in debate, so be careful to inquire how the specification has been derived. During the final operational test, the front panel test port and internal 50 ohm termination will be used. Static sensitivity testing follows a set procedure as fully presented in the operations manual. Once the TTA system is installed, the test for sensitivity changes as the signal generator is connected to the front panel test port instead of at the TTA antenna input. The signal generator should be set up as described in the operations manual to produce a test tone for SYNAD testing or the appropriate pattern to test for bit error rate. In this test, a receiver and a SYNAD or bit error rate meter are connected to the output connector. Put the 50 ohm load in line in place of the antenna using the front panel terminate button, or use the front panel display menu to put the unit in the terminated mode. Static sensitivity is measured as before by adjusting the output of the signal generator, increasing the output until the SYNAD meter reads 12 dB or a 5% bit error rate is reached. Record this generator value, as it will be used to calculate the effective receiver sensitivity value. Take the TTA out of the 50 ohm test mode by pressing the cancel button on the control deck. The final step in TXRX systems operational testing is to calculate the resulting system sensitivity and degradation seen by the system. This measures the baseline of the TTA and receiver systems in the RF environment. Sensitivity will be impacted by how much attenuation is in use, so be sure the attenuator is set as required. This testing should be performed under two conditions, the first under normal operation and the second with all transmitters keyed and producing full power. Remember that all transmitters produce noise when they amplify signals. When all of the radios in a system are being used, the system is fully loaded, simulating an emergency situation with all radios in use, and when system failure or compromise cannot be tolerated. This will also be the time when the system has the potential to generate the most noise. The difference now will be that the antenna is connected, and noise from the outside is coming into the system. The signal generator is connected to the front panel test port on the control deck, and a receiver and SYNAD or bit error rate meter are connected to the rear panel RF output port. The signal generator is set up as before, with either test signals for analog systems or the proper pattern for bit error rate testing. Adjust the signal level on the signal generator just until a 12 dB SYNAD or 5% bit error rate level is reached, along with any incoming signal from the antenna determines the system's effective sensitivity. Be sure to correct the measurement by 30 dB, as the test port output coupler reduces the signal level by 30 dB. Record this value, as it would be used to calculate the amount of system degradation caused by external noise. System degradation is the accumulation of all noise or interference that will cause a loss in sensitivity. The difference between static system sensitivity and effective system sensitivity is external degradation. In 800 MHz systems, it is unusual to have greater than 2 dB of degradation, and if levels are running in excess of 1 or 2 dB, the cause should be investigated, as it will result in a decrease in the range and performance of the system. System performance is usually at its best following site commissioning and degrades from there. As discussed in other training modules, nothing improves with time on a tower. Performance degradation shows up as loss in range, loss of received sensitivity, audible noise in FM systems, and dropouts in digital systems, known as cliff effect. If you are seeing a sensitivity loss on a continuous basis, it is more likely to be an equipment or hardware issue and should be investigated. Two of the most common sources of hardware issues resulting in TTA alarms are vandalism and lightning strikes, resulting in transmission line or antenna damage, failed lightning arresters, or other physical damage to the system. TXRX Systems continues to lead in TTA development and production. Many different models of TTAs have been produced since their introduction in 1995, keeping LMR communications for first responders solid. TXRX has worked with all major LMR radio manufacturers to build life-critical application radio infrastructure equipment. When lives are on the line, second best won't do, and first responder equipment must work first time, every time. TXRX continues to produce state-of-the-art TTAs that incorporate survivability, connectivity, and security for public safety systems. New TTAs are being designed on a platform that will allow for future enhancements and expandability. Newer models are being released with more embedded software, allowing systems to be put into auto setup mode and continual monitoring, sending updates and alarms when needed. Thank you for being part of this training module, for inquiring about TXRX systems and services, and for being part of our technical community. This section was intended as an overview to the setup and optimization of land mobile radio receive sensitivity improvement products and systems. More training modules are available in support of this and other topics specific to products manufactured by TXRX systems. The material is available in short versions and in longer half-day, full-day, and two-day classes. Visit our website at txrx.com for more information. Titles and topics are being added weekly, so please come back often to see what is available. Classes are available at TXRX Systems 8625 Industrial Parkway, Angola, New York, or if your group or shop is large enough, we will bring the training to you. Please call 716-549-4700 to discuss fees and scheduling. Again, thank you for being part of this presentation, and we do invite you back.